Hello students, welcome once again, and today we have a question over here. Solve the equation 1. We have a series over here, so we have 1 plus 4 plus x plus then all the way to x, the last term, equal to 925, and we have to find the value of x. What is the value of x? Now this is a sequence, so we have to find, what we are going to do is that we have to find the nth term of the sequence. But since we have x, then we are going to find the s term of the sequence, because in a normal sequence we have an here, we have a and b equal to a plus n minus 1, then multiplied by the common difference. But because we have the s term over here, we are going to let a n be equal to x, so that we have x here being equal to a plus n minus 1, then 1, 4, and 7. So the first term a is just 1. The common difference there is just 4 minus 1, which is equal to 3. And the same way 7 minus 4, which is equal to 3. So the common difference there is 3. So we have x here being equal to the first term 1, then multiplied by the n minus 1. Then we have d. So d is just 3. So we have x here being equal to 1 plus 3n minus 1, then minus 3. So we have x here as 3n minus 2, and we have minus 2. So let's call this one equation 1. Then let's find the value of n. So what is the value of n? So it's just by so we bring the negative to the, it becomes positive 2 equal to 3n. Then we have n here equal to x plus 2 divided by 3, and let's call this equation 2. Now we are going to find the sum of this sequence over here. So finding the sum of the sequence, we need n minus 1. So we have n minus 1, so we subtract 1 from this side, and we have x plus 2 over 3, then minus 1. So n minus 1 is just we have the LCM as 3. This goes in there, multiplies that, then this goes there, multiply that by negative 3. So therefore n minus 1 here is just we have 2 minus 1, so it's just s minus 1 here divided by 3. So let's call this equation 3, right? So we have this over here. So now the next thing we are going to do is to find the sum of the arithmetic progression. So we are going to find the sum of the arithmetic progression. So I'm going to find the sum of the arithmetic, and the sum of the arithmetic progression is Sn equal to, so we have n over 2, then we have 2a plus n minus 1, then multiplied by the common difference. All right, remember the sum of all the sequence we had over here is just 925. The sum of the sequence is just 925, and that's what we are looking for. So we have that as that. So we have Sn here be equal to, so let me write this as 2a plus n minus 1 d here divided by 2, and let's multiply by the n value here, because we know the value of n, we just substitute that one in. Okay, so now from here we have Sn be equal to, now we have the first term, we had the first term as 1, then we had n minus 1 from equation 3. From this equation, n minus 1 is just s minus 1, then divided by 3. S minus 1 divided by 3. So we replace it here. So we have x minus 1 here divided by 3 as n minus 1. Then a common difference multiplied by 3. Then we divide all of this by 2. Then the value of n we had from equation 2 as x plus 2 divided by 3. So we have s plus 2 divided by 3, and we have the sum of all of this, we had this as 925. So from the question, 925 is equal to, now 3 here gets rid of the 3 over here, then we have 2 minus 2 times 1, then we have x minus 1 here, then we have x plus 2, then this divided by 3, this divided by 2, so we have 925. Then we have 2 plus x minus 1, then 2 multiplied by 3 is just 6, so we have this multiplied by x plus 2, then over 6, right? Because 3 times 2 times 3, so 925 is just we have 2 minus 1 is just s plus 1, then we have x plus 2 here as that, then divided by 6, so we cross multiply, so 6 multiplies that, we have 5550, then we expand this, so expanding we have s multiplied by x squared, s multiplied by 2, we have 2x here, 1 multiplied by x, we have x, 1 multiplied by 2, we have 2, so we have let's send everything to the other side, so we have s squared, then 2s plus x is just 3x, then we have 2x, this crosses to the other side, becomes negative, so 2 minus 5550 is just negative 5548 being equal to 0. Now we have a quadratic equation over here. So solving a quadratic equation, we have to find two values. We multiply, we get 5548, and when we add it, positive 3, and these values we add as 73. So we have 73, and also 76. So 73 multiplied by 76, we are going to get 5548. Then, but we should get negative that. So then if we add this value, we should get positive 3. So we have to put the negative here. So that negative 73 multiplying 76, we have negative that. Then 73 plus negative 73 plus 76, we have positive that. So let's substitute that in. So we have over here we have negative 773x, then positive 76x, then negative 5548 being equal to 0. So we have s squared negative 73x here. Then also we can have 76x minus 5548 here equal to 0. So we can factorize, common one is x, so factorize x out, then we have x here minus 73, then plus factorize 76 out, x minus 73 equal to 0. So this is what we have. Then from here, what we are going to do now is that we have that, and also this and that. So we have x plus 76 here, and s minus 73 here equal to 0. So we have s plus 76 being equal to 0, x is equal to negative 76, and s minus 73 equal to 0. Then x here is equal to 73 over here. So this is what we have, and we have the value of x as this and that. So we have negative 76. So we are going to say that x equal to 76 is not the solution. It's not the solution because we do not count. So we do not count negative square root, right? Because if you have a negative square root, it is undefined, so we do not count negative square root. So therefore we can say that x here is equal to 73. So we have the value of x as 73. Negative 76 is undefined with the square root, so we have x here being 73. So thank you very much for joining me in this section, and I will see you in another section. Have a nice day.